makes the perfect baseball swing? For our project, we'll be talking about key factors of a perfect swing and how these factors relate to information we learned in class, but also completely new information we haven't learned. The importance of our project can have a massive impact on current and future baseball players by allowing them to have a deeper study of the game and can help enhance their game. Some examples may be helping coaches in baseball, preventing injuries, designing new equipment, or strategic reasons. Creating new hitting drills can help players have a different perspective on hitting a home run and give them an advantage when understanding the optimal launch angle.
During this project, one of the big concepts we decided to connect with is vibrations and waves. We wanted to focus on the resonance and standing waves on a string in this concept. For this topic, in order for strings to resonate, a standing wave's forced wavelengths must fit nicely into a string's length for integer multiples of 1/2 lambda.
And there's another rocket. Mike Trout has tied it up with an absolute bomb to the top feet.
The first half multiple of the wavelength is called the fundamental frequency or first harmonic, and it has two notes. As the string continues to increase by the resonating frequency of 1/2, the harmonics continue to increase a harmonic or frequency to second harmonic, third harmonic, etc. And the notes continue to increase from 2 to 3 to 4, etc. Our topic relates to this because in order to attain a perfect swing, the bat must achieve its fundamental frequency or fundamental resonant frequency or bending mode in the sweet zone or center of percussion. The sweet zone or COP on the bat barrel is where the contact between the bat and the ball results in the best hit or the impact location that produces no or very minimal vibrational motion at the pivot point or the knob of the bat. The fundamental bending mode or resonant frequency has two nodes or positions of zero displacement. One is about 6.5 inches from the barrel end, close to the sweet spot of the bat. The other at about 24 inches from the barrel end or 6 inches from the handle, at approximately the location of a right-handed hitter's right hand. In between these nodes is the COP or the center of percussion. And since the vibrational motion of the bat is very small in this region, an impact in this region will result in very little vibration of the bat, or no stinging of players' hands, and a very solid hit will result. For a new topic of physics, the concept we will be talking about is launch angle. We will be explaining the ideal launch angle of a baseball hit and the physics behind it. Launch angle is the launch angle of a projectile's initial velocity when measured from the horizontal direction. These angles are typically 90 degrees or less. In order for the launch angle to be present, the bat must make contact with the ball. 0 degrees occurs when the barrel is traveling parallel to the ground. A positive attack angle occurs when the barrel is moving upward, and a negative angle occurs when the barrel is moving toward the ground. In the absence of air resistance for a given initial speed, the launch angle that maximizes the range of a hit is 45 degrees. But air resistance and gravity are extremely important in physics. To hit a home run, it turns out the optimum launch angle for piercing through the air is in the 15 to 30 degree range.
Stays put, and there's a high fly ball, deep right field. Harper watches it fly.
For the physics behind launch angle, a ball that is hit at a steeper angle with more force in the vertical direction will travel higher but not as far before coming back to Earth, a pop-up. A ball hit at a shallower angle, a line drive, has more power in the horizontal direction but does not rise as high off the field. Also, higher launch angles have a greater time in the air and have a higher max height. The time in air is determined by the initial vertical velocity. Since steeper launch angles have a larger vertical velocity component, increasing the launch angle increases the time in air. Launch angles are commonly used in projectiles, or more specifically, a baseball hit for the topic we are studying.
StatCast is a resource used by professional baseball, and players' average launch angle is calculated by dividing the sum of all launch angles by batted balls. The best formula for the sweet zone, or COP, is XCP equals L squared times COM divided by 2 times D. XCP is the distance from the pivot point, typically the knob of the bat, to the center of percussion. L is the length of the bat. COM is the distance from the pivot point to the center mass of the bat. And D is the diameter of the bat at the point of impact. This formula calculates the center of percussion of a baseball bat. That can be complex and depends on various factors, including the shape and weight distribution of the bat, as well as properties of the ball being struck. This formula is important because it is the best calculation in determining the COP, which is the sweet spot of the bat and the measurement for the perfect swing.